So I have two more examples that I want to show you related to factor and cancel. This next one looks a little strange. Limit as x approaches 0 of 1 over 3 plus x minus 1 over 3 all over x. And I call this a complex fraction when I have a fraction with fractions in the numerator and denominator. First thing we should do is the first thing you should always be doing when you're evaluating limits. We're going to plug in our 0. Plugging in is going to give me 1/3 minus 1/3. I think I see a problem there. Over 0. Yeah, 0 over 0. So I need to simplify this. Well, what we're going to need to do here is we're going to need to first get a common denominator up top. Between 3 and 3 plus x, what is that common denominator? Hopefully you realize, even though it looks like they have a 3 in common, things they have in common have to be parts of products, not parts of sums. So my common denominator is going to be 3 times 3 plus x. I'm going to get the limit as x approaches 0 of, okay, let me try to make it have that common denominator. I'm going to rewrite this. To make my common denominator work, I'm going to need to multiply my first fraction by 3 over 3. The orange is showing up. Oh, good. And the second one by 3 plus x over 3 plus x. And then I have some simplifying to do with this. I'm going to get the limit as x approaches 0 of 3 over, I'm just going to leave it factored out, 3 times 3 plus x minus 3 plus x over 3 times 3 plus x. The whole point of that was to get a common denominator so I could go and subtract the numerators. So this will give me the limit as x approaches 0 of 3 minus 3. Make sure you distribute the negative, so minus x over 3 times 3 plus x all over x. Oh, and the top, 3 minus 3, that's just negative x. So I'm going to get the limit as x approaches 0. Make sure you're writing those limit symbols. I know it's a pain, but you'll lose points on the AP exam if you're not showing that on the free response. So make sure you're being good with your notation. And I get this thing. And I am actually not crazy about complex fractions with a fraction in one half but not the other half. I kind of want fractions in both parts. So how about I turn my denominator into x over 1? And then actually, to divide this thing by x over 1, how about I just multiply this thing by the reciprocal? I'm going to get the limit as x approaches 0 of negative x over 3 times 3 plus x times 1 over x. Or this gives me the limit as x approaches 0 of negative x over 3x 3 plus x. Plug in, and it's still 0 on the top, 0 on the bottom. But remember, this is in the factor and cancel section. My function is now factored. I can go and I can cancel those x's. Gone. Gone. This is going to equal the limit as x approaches 0 of negative 1 over 3 times 3 plus x. Oh, and now I can plug into this thing. And I'm going to get negative 1 over 3 times 3 plus 0, or times 3. Negative 1 over 3 times 3. Do not tell me negative 1 over 6. Please don't say that. Say negative 1 over 9. And we should get negative 1/9 for that one. You are probably going to see one complex fraction on your first quiz and on your test on limits. One more factor and cancel example I want to show you, again, with a little bit of a variation to it. I want to take a look, you can't see that, I want to take a look at the limit as h approaches 0 of x plus h cubed minus x cubed over h. This looks unpleasant. Maybe you saw things like this at the end of pre-calc. I'm not entirely sure how far things went last year with the whole remote learning and all that. But we're going to see that formulas like this are going to be very important in our next unit when we start talking about derivatives and slopes and all that. For right now, I don't really care about what this means. I just want to figure out how to evaluate this thing. First question for you. As far as this limit is concerned, what is the variable? Is it x or is it h, as far as the limit part is concerned? Hopefully you said h, because I'm taking the limit as h approaches 0. So I'm going to start the way I always start. I'm going to go plug in 0 where the h is, and I'm going to get x plus 0, that's just x cubed, minus x cubed over 0. Yeah, 0 over 0. It's done. Not good, and I need to simplify this. Well, I need to use some algebra to deal with this, and I really, really, really hope you're not tempted to go and distribute this cube to the x and to the h, because x plus h cubed really means we need to do x plus h times x plus h times x plus h. If you remember Pascal's triangle and the binomial theorem from last year, you can use that. If you don't, whatever, just write it out and start foiling. How about you take a moment and do some foiling over here? Foil the first two pieces, get an answer, foil them with the third. I'm just going to keep the video going, but you see what you can do. Maybe pause it if you want a little bit of time, and see what you can do with just simplifying with this thing. Before I do more foiling, I'm just going to clean up the top a little bit. xh plus xh, let's write that as 2xh. And I'm going to go foil again. X cubed plus x squared h plus 2x squared h plus 2xh squared plus xh squared plus h cubed minus x cubed all over h. That's a mess. I'm going to combine like terms. That's kind of nice. Those are gone. 3x squared h plus 3xh squared plus h cubed over h. I can go and try to do my plugging in, but I think I'm still going to have a problem. Yeah, 0 plus 0 plus 0 over 0. It's still 0 over 0. But remember, this is in the factor and cancel section. I need to go and factor something out of the top. Looks like they all have an h in common. So I'm going to take out that GCF of an h. See if you can finish this. So I'm going to get the limit as h approaches 0 of 3x squared plus 3xh plus h squared. I'll take my limit, which means plugging in 0 where the h is. Okay, this is weird though because I have multiple variables. Whatever, I'm just going to leave that x alone. I'm going to get 3x squared plus 3x times 0 plus 0 squared. That's going to give me 3x squared. And that's my limit. And I realize it looks a little weird to have like a variable in the answer. Right now, I just want you to see how to calculate these things. In the next unit, in Unit 2, when we talk about derivatives, we're going to see that a formula like this will somehow help us find the slope of the function y equals x cubed. More with that in the next unit.